What does the viscosity of a fluid eta describe? So the basic concept of viscosity is it describes friction between layers of a moving fluid. And a simple model that I'd like to start with to think about this is to say, well, what if I have like some layer of fluid sitting on like a surface? So maybe this is just a table like top surface, but I'm not sure how that makes sense in terms of like a fluid layer flowing across it, but maybe it's really the outside edge of a pipe. But I'm just going to draw here and say, okay, let's make this, let's give us a little fluid layer here, and I'm going to give it some boundaries here. Usually when one thinks about viscosity, the layer should be really, really thin, but since I have trouble drawing a really thin layer with any accuracy at all, that is, I'm going to make my layer slightly thicker here. And so if this fluid, let's say we want to have it moving across this surface with a velocity v, if there is friction here, we're going to have to apply some kind of force. It might make sense that we could kind of apply a horizontal force along the top of that layer. It's kind of like, if you imagine like there's this, maybe it's like a layer of fluid on the tabletop, and maybe it's like Jello or something, and then you're taking your hand and you're trying to make it push along the surface. That might sound a little disgusting, I think, if you imagine doing that with Jello, but anyways, but that's maybe a way of thinking about like what's going on here. But in reality, that would probably be other moving fluid, like another layer above it of moving fluid would apply that force to this layer that's here on this surface. And oftentimes in reality, instead of a surface, this would be this would be like between two other layers of fluid to be more realistic, but that's harder for me to draw. So okay, we have that force. If I describe my layer as having an area A and maybe a thickness, I'm not sure what variable to use, and I'm going to cheat a little bit here because I don't know if you've ever been in that moment where you forget a physics formula. It happens to me once in a while, but fortunately I've got an answer here in my slide, and it's going to help us out because we have this formula here that relates the shear force that I'm describing. F is equal to eta, again for the viscosity, times that area A I just defined. But then there's also the V, which is the speed of the layer. And there's L. What would L be? L is that thickness. So that was the thing I was struggling with. Like, what do I put for the thickness? So I'll just put the L there to kind of represent the thickness of the layer. If you look up viscosity, you look up a formula for it, you might be likely to find, instead of this formula, like the formula I've written here in the slide and on the whiteboard, or copied there because I forgot it, right, is the formula for the force, which is actually kind of an easier one to get to, thinking about it conceptually, even though I forgot it. But it's common, if you look this up, you might find a formula for eta, and I think, I might not remember what it is unless I look it up online perhaps, but I think I could find it by just using some algebra, because we'd have, if I multiply both sides by L, that's going to multiply that force, and then if I divide by speed and area, I'd get a formula that looks like that. And you might see that in some different forms, but again, that's just another formula that's there for viscosity. Now, for our purposes, this formula was not listed on the key concept slide, and the reason why is it's great to know this, is great to be able to look this up, but in terms of actually applying the ideas of the Poisson flow model to real situations, most of the time what you're really interested in is that resistance formula and how that relates to pressure drop and flow rate. So more likely you want to look that up, and that's already, there's a bunch of steps that have happened between this basic definition of viscosity and how you get to that resistance formula, and you don't need to redo that every single time you do a problem. So again, you can just use that, but this is just here so we know that this also exists.